Here we are going to be continuing from our chapter 3 review problems, doing chapter 3, page 252, problem number 51. I was only able to do a little bit on this, so I'm going to continue doing problem number 51 again. So the equation that was given to us was y equals to half x plus 1. In this case, the slope was half and the y-intercept was 1. If we were to draw the graph, 1, 2, 1, 2, -1, -2, -1, -2. We start off with b equals to 1 as a y-intercept, as a starting point. Okay? In which case we have to follow the slope. Slope is half. That means rise 1 and run 2. Your second point is here. So if we were to graph the line, it is going to be this. This is the line that we were looking at. This was all covered in our previous video. The second method I'm going to show you now. We actually ran out of time in our previous video, so I'm going to show it now. So the second method is doing your x and y table. So in that case, what you do is you make this little table, x and y. You put 0 over here, plug the value of 0 in this equation and see what you get. If you put 0 in this equation, you get y equals to 1. Let's do it over here, which is y equals to half times 0 plus 1, which gives you, this cancels out, y equals to 1. Now you need another point. I like using 0, so I'm going to put y equals to 0 over here and plug the value of 0 back into this equation, which gives us 0 equals to half x plus 1. Transfer your 1 on this side, which gives you -1 equals to half x. In order to get rid of the 2 from the denominator, you multiply 2 on both the sides, which ends up you're getting as -2 equals to x. Therefore, you get x as -2. I'm going to change my pen, pick up an orange color just to see and graph it on the same equation. The first point is 0, 1. 0, 1. This becomes my first point. The second point is -2, 0. 1, 2, -2 over here. And 0. This is the point. So there is a little bit of a difference because this graph is not drawn according to scale. If you were to do it on a graphing paper, it would exactly lie on this line. And this would be the line that you would get. Either way, using the method of slope-intercept form or making the table, you would end up with the same answer. So until unless they ask you what method to use, it is your choice. And you can choose whatever method you want to do. Okay? Now moving on to the last problem in this section, which is problem number 85. Problem number 85, okay, and it says we need to, the cost C in dollars of driving a rental car X miles is given as C equals to 0.2x plus 35. Now let's understand this equation. C is the cost, which will tell us the dollar amount. X is the miles, which is measured either in miles, if you are going to be doing the English system, or in metric system, it is going to be meters, kilometers, and so forth. So here, this is the way equation is. Now, first part of the problem is how much would it cost to rent the car and not drive it? That if you're not going to drive it, that means your X is going to be 0. That means I can actually put my big fat finger over here and see how much would it cost. It would cost 35. 35 what? $35, because we are doing it in dollars. So if I were to do it this way, C is equal to 0.2 times 0 plus 35. This goes away, you get C as 35. C is in dollars, therefore you end up $35 as your answer for your part A. Now part B is how much does the cost increase with every additional mile? So C equals to 0.2x plus 35. Now, what is 35? 35 is called the fixed cost. Basically, when you get the car, this is what you're going to pay no matter what. Even if you get the car and have it parked in the driveway, it is going to cost you $35. But for every mile that you go, it is going to be a function of 0.2. So if you drive 1 mile, it is going to be 0.2 times 1 plus 35. If you drive 2 miles, 0.2 times 2 plus 35. For 3 miles, it is going to be 0.2 times 3 plus 35. Now, do you see? This remains the same. Only change is over here. So for every additional mile, you're going to be only paying $0.2 extra. So every mile costs you $0.2 or 20 cents.